Hello everyone and welcome to the first episode of Naru's Corner. I messed up this intro so many times that I just apologize for any hiccups that I might do, that might happen, during the video. I'll try to minimize them, but I won't re-record them because we would never get finished. Anyways, this is what we will be creating today. It is a terrain generator or map generator, I don't know, it creates a miniature of the terrain that you're standing on, and yeah, that's it. I'll just turn it on without further explanations. And as you can see, there is a progress bar that shows you how the raycasting is going, because you need some feedback for the players so they know that something is happening, right? And there we go. Individual pieces are moving to their positions and it creates a version of our terrain. You can then use this to, I don't know, hide treasures and just, show the position there. Or you can add script for displaying enemies there, for instance. It would be the same principle, just you have to update it. Yes, let's just jump to editor and we will see the scripts. So here we are back in the editor and we are in a fresh new map, just so nothing is distracting us or anything. And we will split the scripting part into 3 smaller chunks. First one will be, generating the grid itself. The second part will be raycasting to the terrain, and the third part will be obviously moving the parts to their correct locations. Yeah, so we will start by placing a empty global storage like so, and we will create the first instruction that will be spawn grid, right? And we will need 2 parameters: the center position of the, sorry, not writing for some reason, oh yeah, center position, and the second one will be the size of the grid that we want to create, right? And you should always try to pass as many things as parameters as possible, because it makes your code way more easier to adjust later than if you hard code it inside. It's just good practice to do that. And so we will start by explaining how the spawning of the grid works, I guess. And it's pretty easy. You just take some loops. I will use just these repeat, okay, 2 repeat loops, one inside another. And how this works is that one loop is for rows and the inside one is for the columns. Okay, if I switch quickly into I've prepared a little grid here. This is just a small 4x4 grid, okay? And if you let these loops run, how it works is the outside loop will have a 0 right here, and the inside loop will run through 4 times, okay? So it will be 0, 1, 2, 3, and then once this finishes, it will be called again, so it will jump over to 1. And here inside 1, it will be again, the inside one will be called again to 0, 1, 2, 3. Then again, once again, jumps over to 2. Oh, this is terrible, I'm so sorry, I thought it's gonna look better. Anyways, yeah, this is how it works, okay? So the inside loop runs all over again every time the outside loop jumps. And this is how we're gonna complete our grid, okay? We'll just, in each of these fields, we're gonna spawn a game logic. And I think we used trigger zones, small trigger zones, and then we'll just move the position by 1 or whatever number we choose. Depends on how big our screen should be, right? So let's jump back to editor, and here we will just test out that if we place size in here, because we want it to be the square, right? So both will have the same, both will be the size that we pass in here. And then we will just spawn some test test objects, and that will be, let's say, torches. Torches are really visible, really well visible. And for the position, we are gonna create, for now, I will just pass in center position just to make things easier, okay? So let's pretend this is the not center position but the corner position, because we can't start from the middle, okay? So this will, I will name it as simple position. And now this is the start, so it will be spawning on this position, but each time the inside loop finishes, it will, or inside loop is called, it will change the x of this position, set x of this position, let's move it, yeah, to, and now we're just gonna get the x vector. This is just, this piece just serves to get one piece of the vector, okay, just the x value, and we use number. See, just at this point we're dealing with numbers, so you just get the x vector of position, which will be in this case from start 0 plus 1. It means that each time this runs, it will add 1, so it will be called at 0 0 0, then this will be called, and it will be called at 1 0 0, this position. And each time this whole loops run through, we want to increase the column, right? This was for rows, and for column we want to increase one, and that will be the z vector in this case. So get z and set like so, and basically the whole thing copied, except that it's going to be z vector. And of course this is there's one more problem, and that means that we have to move the x back to 0 once we have finished with that. So for now I'm just gonna set hardcode 0 here, just so you see that, because if I didn't do this part, it would just continue. Like, see, if I switch the scene again, if I didn't set this second one to 0 again, once I run through this first, that at this point inside there is going to be 3 in our position, right? And if I jump back here, it would be called with 4, which means it would be here, here, and so on. So we wouldn't restart the x position, so our final grid would be somewhere here and here. Yeah, you get the gist, right? Yes. Anyways, switch back. I hope you get what I mean. Just, okay. So it's like this, and now we just call it at the start, just so you see the end result. And we will call it with the position of 0 0 0. Okay, 0 0 0, and as a size we can choose whatever we want. Let's say 20. This should spawn 20 times 20 grid. Okay, so what I had to do is that I had to decrease the number to 5 by 5, because 20 times 20 of torches was just unbearable for my computer, and it was just laggy as hell. So yeah, there you can see that we have successfully spawned 5 by 5 grid of torches, and all that's remaining now is to change the torches into the trigger zones. Yeah, this is the same, exactly the same principle. Oh right, one thing to change is that right now we are just using this center position as a corner position. So how you do that, of course, is that you will take this vector operation and you will take the center position and subtract from that a new vector, bear with me, this might seem a little weird, but and from there you want the size divided by 2, and this is like, right, so we need to get to the center position. So you take the half of the size of the grid and then multiply it by the size of the distance between the two blocks. I think that we are going to create ours with 0.1, let's say, and the same thing will be to the Z. Okay, so what this should do is that the position, starting position, will be moved to the side, to the corner. So if I change it here, it will be moved to, it will be moved to this block. Okay, and this will become our centerpiece. Oh, I have 4x4, so obvious that I don't have a centerpiece. That would be somewhere here. Here. Oh, this is terrible, isn't it? Anyways, yes, so now once we have the corner, we can change our size to 0.1 as I've told you. So 0.1, 0.1, and we will change the spawning block to something more friendly. And since I have used the trigger zones, I think we could use them as well, just so it makes sense to you. Trigger zone, let's change this to block, and I said it will be 0.1, right? 0.1, 0.1, and 0.05, just so it's flat. Even 0.01, why not? Yes, so this will be the single piece. Okay, let's set it to animated, just so we can move them later, and visible, so that we can see them in the world. Let's set them purple for now. Purple is a great color. And now we will save this template in, well, game logic template, like so. Since we've already set everything up, we don't really need any further setting. We'll just delete the original one because it's already saved. And just to keep a track of all the blocks that we spawn, we add a game logic label, and to this label we will assign all the blocks that we spawn. Okay, it means that later we can just access them easily, and for that we need to spawn game logic template, as you can see, and we will spawn it into a local variable. If you do it like that, you can then use the spawned block in multiple places, you know, afterwards in the code, so it's way more easier. So okay, position, and then we will attach a label to it. Of course that you could spawn it straight in the attach label tile, but you know, you never know if you might need it again. So variable and a label. I will rename this variable just to be nice. It will be new block. Okay, so we have assigned the new block to the game logic label, and we will change the size to, let's say, in this case I think we already can do 20, and to see that we are already using relay center position, I will place a rod. No, oh, of course I need to place it here. Rod, okay, it's steel rod. Let's rotate it, and this is going to be our center point for the grid. So get position of this, and one thing I'm gonna do is I am gonna increase the y value of this by 0.6, just so you know the point for this, the pivot point, is in the middle. So this is where our grid would be, and we want it higher than that, right? So just so we can see it better, and we don't have a rod sticking through that. Yes, and one other thing to watch out for. I'm sorry, it just pops up as I'm talking. One more thing is that when you're doing this, you want to save the original X value of the center position, because if you try to restart the X position to 0, it wouldn't match this position, right? So this will be the origin X. Does it make sense? Probably. Get X of the position, yeah. And we are just gonna, because right now it's just a pointer, so what I'm gonna do is just add 0 to it, and anytime you do some operations with numbers or with the vectors, sorry, you create a new value, and it stops being a pointer. Okay, so even if I change the position now, the origin X is always going to be same. So here, when I'm restarting to 0, I'm going to be actually restarting to origin X. Okay, done. And let's try and test it now. Here we are, and as you can see, we have a beautiful grid of 20 by 20 blocks, and the steel rod is in the middle, give or take. Okay, so that would be the first part of this video. And for this, okay, so let's move to another section, which will be, of course, raycasting and then saving these positions that we find using that into a game logic storage for each individual point. Okay, so place game logic storage, open it, and we will create a new variable there called position. And what we will do is that we'll go back to our global storage, search for add storage tile, and you need the game logic one, of course. And here, back in our spawn grid instruction, we will add the storage to the newest spawn block. Okay, this is how we make sure that each of those blocks will have its own storage, so it can have its own position saved. Okay, and we will create another instruction. We will call it a raycast, just so we know. It seems pretty easy. And we will need 2 parameters. One of them will be a, sorry, not typing again, I don't know what's wrong with me, current index, okay, and a scale of the map, scale of the size of the terrain that we want to capture on our map. Okay, and to just quickly explain on what we're gonna do here, I will switch the scenes again. Okay, I've drawn this beautiful picture. So this is the center position, this is our rod, okay, and this will be the one individual point that we have on the table, or in the grid in this case, and we are gonna take position of this current point, subtract this center position from it. That means that we are gonna only get this part. Okay, if you subtract this center point, you're gonna only have this part. Okay, we're gonna scale it up by the scale, so I don't know, by 10, 20 might be too much, so let's do like 7. Okay, 7 is gonna be ideal. Let's scale it by 7. That's gonna increase this. This is gonna be our new point that we're gonna use for raycast. So it is gonna move, I don't know, for 3 or 4 positions next. We're gonna raycast from that to the terrain, and the position that we find out, we will save the height into this point. and then we'll just discard this point because we only need it for this moment in time. We're never going to use them again. Okay, they are just helping points to find out the height at the position, and that's it. Okay, so let's get back to the scene. And I'm sorry. Yeah, so first we are gonna need a new variable that is gonna be our current index. Okay, so current index, we're placing it into a local variable just so we can work with it inside the function better. Okay, so another local variable that is gonna be our current block. Okay, that is the block that we are gonna use in that iteration of the function. So how we're gonna use it is a get array. Now we're gonna search for logic object style. They get logic objects. Okay, this tile is for getting all the logic objects from a label. It means that it's gonna be an array of all those objects that we have saved, all that grid, and we are gonna use our current index as an index. Okay, so now we will need their position. Okay, so I will create two more variables. Don't panic, but we'll need two more variables, and that is going to be A and B. Okay, let's say that A will be the position of the rod, and B will be position of this current block. Okay, I'm doing it just, you could do it all at once, but this is way more, how to say this, way more visual, and I hope you can understand it better like that. So we're gonna need get position. One is gonna be entity because it's for the rod, and one is gonna be game logic, right? So here and here, A is gonna be the rod, B is gonna be our current block. Okay, so now we have two positions. What we need to do, because if you remember correctly, the rod has its point, the pivot point here, down here, so it's not in the same height. So to avoid any mistakes in distances, you know, we will restart the y coordinates of both of these. So set y vector, and we will set both of these of A and B to 0. That means that right now it's just simple distance between them in the x and z, and y has no part in this at all. Okay, so for the last time, well, not last, but one more variable, which will be called the position, and this will be the position that is moved to the, you know, the scaled one. Sorry for the hand gestures, I know they're terrible. And for this there is a scale tile. Okay, you can scale this, you can scale vector 1 by vector 2. Okay, so for vector 1 we are gonna use this operations with vectors, and we are gonna subtract the position B, that is the position of the current block, by position A, and that means that by this we're only getting the piece of, as I've showed you, the piece from the center position to the block, and we're going to scale it by our, if I create a new vector, this scale. Okay, scale. It doesn't have to be at Y, I just place it there, you know, just to be sure. Okay, so what we're gonna get from this is the scaled up position, and now comes the time for raycasting. So we are gonna use the terrain one. There is a second raycast, but this one counts entities as well. So if you hit some tree on the way down, it wouldn't call the terrain, so it might cause some weird abnormalities in the once you call it. So I would suggest using this one. And as origin, we are gonna use a new vector. Sorry, I totally forgot. This is a scaled up position, but it is a scaled up position from the center, and we need it from the position of the center, right? So we are actually gonna need to add the original A. This is the original position of the, no, sorry, yes, the A, and add to it the scaled up piece. Okay, I hope you understand. I'm so sorry, it's so confusing. So now we're finally gonna get the position as a origin. We are gonna raise it up, so it's gonna be position plus, let's say, 50, to make sure that this position is always above the terrain. You know, because there might be some mountains, but I don't think it actually goes above 30 or 40, so 50 you should be safe. And direction is gonna be -1 on the y-axis, so it's always facing down. As a max distance, I am gonna set 70. It should count with all the, you know, downhills and probably even a sea, I hope so. And in here we are looking for on ground hit event. Okay, so if it hits terrain, it is gonna call this with a hit position, and here is where we are gonna use the game storage that we have created, the game logic storage, sorry. So here in the parameter of which logic it should be, we will use the current block. Okay, and in the position we are gonna, actually it doesn't have to be position, because we don't need to complete position. We can use only a y vector, because we are not gonna be moving them to the sides. We only need to move them up, okay, based on their elevation. So get y position, get y vector of the hit position. So at this point our position will be only one number, which will sign the height. Okay, on mist we don't really care about it. We can just debug there some console message that might say like missed. Okay, that means that it didn't find the terrain. It's just in case that we wrote something incorrectly. And after this, what we've just done is just we've run it run it once, and we need to run it again while we still have another point to check. And how we do this is that we are actually gonna call the same function from itself after a slight delay. So we are gonna use an if statement, and we are gonna say that if the current index that we have, if the current index is smaller than length sorry, I'm just thinking, then the length of those logic objects, that means this returns just a simple number of how many of those objects you have. Okay, so if the current index is smaller than this plus 1, of course, because it always the index is always from 0, and you know count is from 1, so you have to add 1 to that. So if it is actually smaller, we can call the raycast again after some delay, of course, because you don't want this to be instantaneous. You want some space afterwards, so it's gonna be like 0.1. Okay, you can probably use something down to 0.03 seconds, but now just for the sake of the tutorial, let's say 0.1. And no, you know what, I'm gonna use 0.05. That might be good. And as a current index, we are gonna pass, oh sorry, yes, I did not increase the current index. That this might have been embarrassing. So here we're just gonna say that current index equals current index plus 1. Okay, and now we're saying that if the current index, which we have increased, is smaller than that. If it's not, then we are not going to call it at all, because we will know that we are done. Okay, afterwards we will be calling the move function that will actually move those points to their positions. But for now, let's just focus on this part, and this is at the current index will be the current index that we have created, and the scale still remains the same, right? So we are not changing that anywhere. And so this will run all over and over again while it still has the blocks, while it's still the current index is smaller than the length. But once it reaches the end, it means that all the points have their positions assigned, and that is when we're gonna want to call the new function for moving those points. Okay, we're finally at the final part of this video, and that means that we are getting to actually moving those parts. For this purpose, I have added some small terrain chunks to, because it wouldn't work if we were trying to load the flat terrain. It wouldn't be pretty and not very interesting. Okay, so let's just create these small hills that will be loaded there. Okay, and now just edit script, and first thing we're gonna do, I think before creating the last instruction, I am actually gonna increase the size of the grid that we are spawning to like 35, 36. Let's leave it at an odd number, at an even number. And okay, that just means that we cover more ground. Okay, and now let's just create the final instruction that we will call very cleverly move. We don't need any additional information past there, because all we need are the y coordinates, right? And to make sure that we loop through all the game logic objects that we have, all those points, we are going to use for each loop, and we are going to use this get logic objects tile again, because this will allow us to go through all those objects, and each and every one of them is this item. Okay, so it's gonna go through them, go through all of them, and it will make sure that we use every single one, whatever we define. So we're gonna use delay because we don't want to move all of them together, right? It would look stupid. Although it might not look stupid, it would just take a lot of create a lot of strain to your computer or on server if you are trying to move all those blocks together. So what we're gonna do, we are actually gonna use delay, and here we are gonna use a distance. Distance is a tile that will return a number. Sorry, I'm just going to search for it. It will return a number that represents the distance between two positions. Okay, and then as a first position, I'm gonna steal it from here. We're gonna use a get position of the center rod, and the second one will be the position of the game logic. And the game logic will be the item that we are currently on in that loop. Okay, so distance, and we will divide this number that we got by, let's say 3 or 4, just to make sure that it's not too big, so we don't wait for that long. And here we will just say move to object. This is it. The object will of course be the item, and as the position we are gonna use a new vector, and it will be this position of the item, because we don't want to create a new position, we just need to change the y value of it, right? So we are going to use the position, and for the y we are going to go to game logic storage. We are going to get the y position of the item, right? Because each one of them will have a different one. So the item, and now we just have to divide this by, let's say 30. No, let's say 50. Okay, So we're just making sure that we are not passing the actual Y positions, because some hills have like 30, right? So you don't you don't want your table to just jump high in the sky, you just want it lowered. So yes, and we are just gonna add it to the original position. Speed, let's say we're gonna say 2, and smoothing 1 is the maximum. So it just creates this effect that it starts slow, goes faster, and as it is closest to the to the position it should be, it just slows again. You know, the smoothing. What am I to explain, right? So yeah, and we are gonna call this move right when the scanning is finished, right? So we just scan all of those, and once we have all those positions, we're just gonna move them where they should be. Okay, I think it is the right time to try this out. But before, one single thing. So right now it takes way too long, okay? This raycasting, because it goes one after another. So what we could do to make this a little better, we could use loops again, and we repeat. We could use repeat, and here we could decide what number of raycasts should we do at once. You know, because of course it's not smart to do all of them together, but if we use, for instance, like 10 at once, that could work, right? So we would place, well, yes, we would place all this except the if statement, yes, like so. Okay, so I've just enclosed all of this, all of this into a repeat statement, and that means that it will do this 10 times before it checks for the current index and calls the function again. And to make sure that we don't run out of blocks before this 10th is called, we need to clamp that number, right? So clamp. What clamp number does is that you actually define a maximum number, and as a number we are gonna use 10, and here we are gonna use, what are we gonna use? The max number, yes. It's gonna be the length of the array minus the current index. Does it make sense? Because that is the number of blocks that is missing, right? Minus the current index. This is the length, and an index will be, for instance, we have 400 blocks, and we are at an index 344. No, sorry, 94. So there is only 6 blocks remaining. So you don't want to call it 10 times. You want to clamp it at 6, right? So this makes sure of that, this clamp number. So what we've just done is that it will go to that 10 times faster, because it will be performing 10 raycasts every call. Okay, now it's time to test it out. I hope you understood this. I'm so sorry if you didn't, but you can always ask at our forums or comment on this video and I'll try to respond. Now let's hope it works. I would feel so bad if it didn't. We should have tested it through more. Always make sure to test it out before you finish it. Okay, so let's turn it on. Now it should be raycasting, and this is just some debug I've tried to do. And you see it works. It has created, you see, has created a duplicate of our map. What these logs are, just so you understand, these are the positions of the raycasts that were hitting the ground. I will show you right away where I've put this. It's just to check that you can check the size that you are using. See here in the script, I have just added this spawn entity. You see on the right in the raycast, I'm spawning the entity on the hit position, and that is because I wasn't sure that it's actually working, since I have been calling from the lever the raycast with a small scale. If you remember, I had like 7, right, at the scale. So it created such a small area that it didn't hit any of those hills, and I thought that my script wasn't working. So it's always good to check like this if you're actually spawning, or sorry, array casting at the right spot and all of those other things. So always make sure to write enough information to logs, or at least to console, or create some debug windows. Sorry, I'm just rambling at this point. Anyways, this is it. The only other thing that was there was the progress bar, but I don't think I have time for that today, and if you will want, I will create that in the next video. But for now, I will just say goodbye, and if you have any questions regarding this, I'm sure that there will be some category in our forums on Ylands, from Ylands team created for this, so don't be afraid to ask anything. There are no stupid questions. Generally, I don't think so, at least. And I'll try to respond to every one of them. So see ya, guys.